All right, we're live. So, hello to everybody who is absent. You want to say hi to everybody who's not here? All right, see, they miss you. They miss you. All right, we have solved systems of equations so far that have been two equations, two equations, two equations. I don't want you disturbing him. Yeah, yeah. And we did linear, and then we did linear, quadratic, and then we also did a little bit of those inequalities. But a system so far has been two equations with two unknowns. And in this section, we kind of go one rung higher on the unknown ladder. We're going to have three unknowns. And guess how many equations we're going to have? Three. You'll always need as many equations as you have unknown values. Right? If you just have an x, then you just need one equation. If you have an x and a y, you need two equations. And today we're going to have three variables, which are x, y, and z. Yeah, good call. That's z. We're going to use x, y, and z. X, y, and z is useful because that's when you usually talk about, in a coordinate grid, you talk about three-dimensional, not just two-dimensional, which is kind of, we live in three dimensions, right? Um, the process is not as straightforward, though, as it was with the system of equations. Because basically, let me kind of walk you through what we're going to be doing here. You have equation 1, 2, and 3. And we can't solve all three at the same time, but we do know how to solve two at a time, don't we? So what we're going to do is we're going to take 1 and 2, and we're going to solve. And then we're going to take 2 and 3, and we're going to solve. This is going to give us equation 4, and this is going to give us equation 5. In other words, we're just doing it twice. We're just going to do it twice. And we're going to have to use one of the three equations. We're going to have to use it more than once. In other words, he could be your pivot guy. I'll work with you, blah, 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 and then I'm going to work with the other guy. And now we have two equations. Guess what we do with equations 4 and 5? Yeah, now we solve to get the answer. And once you get the answer, then all you have to do to find the other two variables is like bunny hop back up to get your answer. So let's say here you get answer x equals, you bunny hop up, you'll get y equals, and then you bunny hop back up one more time, you get z equals. Now, if you understand my diagram, you paid attention, right? We'll work this out with actual equations, but it looks like a distorted treasure map that you have no idea where you're supposed to be or start or go, but it will make sense. Now, that diagram is substituting all of these words right here. Okay, all of these words. Here's one that's worked out. Let me kind of just walk you through this one. We have three equations, okay, right up there. It's a system. They have the open brace linking them together. Equation 1, equation 2, equation 3. It doesn't matter which two you pair with each other, so long as it's one, at least one of them is different. Each time. So I got equation. This person is not my work. This person used equation 2 and 3, and they solved them to get equation 4. And then what? Well, then they're going to have to get which one have we not used yet. If we did 2 and 3 here, which one have we not used? We haven't used 1. So now we got to get 1 involved. But to get 1 involved, I need another guy. So which one of the 2 and 3 do I use? It doesn't matter. You're going to get 1 involved, and then it could be either one of the other two. You're going to solve that and get equation 5. And then you're going to get the equation 4 and 5, and then you're going to solve those to get your answer, and then you bunny hop back up, okay? I'll show you how this works. It's actually a lot easier when you do it. If you just talk about what you're supposed to do, it's not as easy, right? Okay. Let's try it out. Solve the three variable linear system. Okay, step 1, to help yourself stay organized, we're going to label these three equations. 1, 2, and 3. 1, 2, and 3. All right. I'll choose one of the equations. Okay, I'm going to choose 3. I'll choose 3. Okay, so I'm going to choose equation 3, which is x plus 4y minus z equals negative 5. And then you tell me which other one we want to use. 2, okay? So if I'm going to use 2, 2 is x plus 3y plus 2z equals 5. All right, so if you want to write it up above there, this is equation 2 and equation 3. Now, the way that we're going to eliminate a variable is not by substitution. We are going to use elimination, all right? Which variable is probably the easiest to eliminate here, the x, y, or z? The x. Why, Wyatt? You're right. There's nothing in front of it. It's a 1x and a 1x, right? Now, the z wouldn't be bad either because at least the top one has a 1, the bottom one has a 2. So let's go ahead and I'm just going to put a subtraction sign here. And we'll go through and we'll subtract. No, you know what I'm going to do? We did this before and it was confusing. Let's put a plus sign there and we'll just put the negative in front of every term. It's like distributing the negative all the way through. Yeah, on each one. I want my negative on each one because I don't want to have to keep it in mind. No, because what I'm trying to do, remember, is eliminate a variable, so I want them to be opposites of each other. And because the top one is already positive x, I just distributed a negative in the bottom and make it negative x. And now I can add vertically. What happens to these x's when I add vertically? They're gone. And I'm left with 4y minus 3y is y. And I'm left with negative z plus negative 2z is negative 3z. And then negative 5 plus negative 5 is negative 10. This is now equation number 4. Equation 4. Now, we've done that before just with 2 variables. So it was the same idea, right? Nothing new. Show me your notes. Get in the notes. Where are your notes? Notability. Yeah. Come on. Play along. Come on. Yeah. All right. So now I'm going to come over here to the left side, and I'll choose equation 3 again. I'll choose equation 3. X plus 4y minus z equals negative 5. And which other one do I now have to get involved that I haven't got involved yet? Number 1. So we'll do number 1 and 3. And you could have done number 1 and 2. It doesn't matter, but you had to get 1 involved on this one. He didn't want to be left out. All right, so that's x plus 2y plus 3z equals 9. And it doesn't matter, again, which one you write on top and which one you write on the bottom. That doesn't matter. So you could have put equation 1 on top and equation 3 on the bottom. Now, before you proceed, just make sure you have one of each of the numbers included up there, right? I got the 1 that I'm using right now, and then I've got the 2 over here, and I've got the 3. So I have used all 3 of them. That's important. Okay, now here's the other thing. Because I got rid of the x on this one, I got to get rid of the x on this one. So once you decide over here, you're stuck doing the same thing over here. Same variable. Well, it just so happens that it's just as easy, right? I'll come through here and I'll put that as a negative, 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 negative. And then I'll add vertically. And I get the x's to cancel once again. 4y minus 2y is 2y. Negative 4z and minus 14. Oops. Hang on. There we go. And that's equation number 5. Yeah. Now, again, at this point, you should have the same 2 variables in both of your equation. If not, you eliminated 2 different variables each time, and it's supposed to be the same one. Now let's come down here and we'll write these together. So I get y minus 3z equals negative 10, and 2y minus 4z equals negative 14. And now we're finally at something that we are familiar with. We see a system of equations with 2 variables. We're kind of back in our comfort zone again. We can solve this by elimination again if you want, or you can solve it by substitution if you prefer substitution. You tell me. Let's try substitution. Okay? I can solve the top one. I'm just going to do this. I'll put an arrow like that, and I'll put y equals positive 3z minus 10. And then I'm going to plug that in down here. So I get 2 times y minus 4z equals negative 14. And what am I plugging in the parentheses? 3z minus 10. Yeah. So this goes in here. And now I have a single equation in terms of z, and now we're back in algebra 1. I just distribute, expand it out. 6z minus 20 minus 4z equals negative 14. And I got 6z minus 4z is 2z. And then I bring the 20 across. 20 minus 14 is 6. Divide both sides by 2, and you get z equals 3. I'll be a monkey's uncle. All of that, and we got a nice little integer value there. Z equals 3. Okay. Now, what do I mean by bunny hopping back up? I need to find the other two values. So if I come back up here to this system of equations, like we've been doing, I can find the other variable. Now I'm going to plug it into y equals. So I get y equals 3 times z minus 10, and z is 3. So that gives me y equals 9 minus 10, which is negative 1. I'm going to go ahead and box these as I find them. That can be helpful too, because you're kind of jumping around everywhere. All right, now I get to jump up one more time. I could jump up to either one of those systems. So if you look at the top there, way at the top, which of these three would be the easiest to plug into? I would choose number 3 as well. Yeah, just because there's two coefficients that are 1. So now we'll jump back up here, and I'll plug it back into this one. So I get x plus 4y, where y is negative 1, minus z, which is 3 that we just found, equals negative 5. And now we saw that for x. So I get x equals, that's negative 4 minus 3, that's negative 7, equals negative 5. And finally, I add 7 to both sides, and I get 2. So we found everything kind of in reverse order, right? But we got all 3. And now all we have to do is list it as an ordered pair. You're listing it as an ordered pair x, comma, y, comma, z. Well, it's an ordered triplet, I should say. So we're going to have 2, comma, negative 1, comma, 3. So the order is very important, like an ordered pair, ordered triplet. Make sure you're putting x, y, z, not like z, x, y, or something like that. How'd that feel? It wasn't that bad. It's the first time through, so I understand maybe you could be kind of like, what is it? But it gets easier. All right. Comments or questions so far? Happy day before green bean casserole day. That means tomorrow's green bean casserole day. An elderly couple is sitting in church, and the wife turns to the husband and says, honey, I just let out one of those silent farts. What should I do? And he goes, get a new hearing aid. Or get a new battery for your hearing aid. Yeah. Oh my gosh, how embarrassing. Anyway. And then all the congregation was looking on and said, amen. Right? All right. Let's move on to the next one. It's very, very similar. Solve the 3 variable system. Now this one, that's not cool what they did. You see that second one with the 1/8 out front? Stupid 1/8. You know what I'm going to do? I don't like those fractions. So I'm going to multiply this side by 8. And I'm going to multiply this side by 8. And now I'm going to rewrite my system. The system will now be y equals 10 plus 2z minus x. And now I'll have 8x equals, and the 1/8 and the 8 divide out. So I'm just left with 5 plus 9y plus z. And then the bottom, 3x plus 4y plus 2z equals negative 10. You're done already. You can set it on my desk there. Thank you. Now, in order to do the elimination, you have to have your terms coinciding with each other. Okay, so what we like to have is ax plus by plus cz equals d. That's how all three of them were in the first one. I don't have that so far, do I? The bottom one looks good, but the other two need to be rewritten one more time. So sometimes there's a little bit of housekeeping. So I'm going to bring the x and the 2z over, so I get positive x minus 2z plus the y equals 10. So that one's written in that format now. Check. The second one, I already got the x over there, so it's 8x, but now it's minus 9y minus z, and it equals to 5. And then the bottom one was looking good. So now here's our starting point, really. We're finally to the point where we can start. I've got a column for x's lining up, a column for y's, a column for z's. Wait, I didn't write that one correctly. Yeah, I got to switch those around. Yeah. I got a column for, now I have a column for y's plus y minus 2z. And then I got a column for constants on the other side of the equation. Now, it might be helpful to think about before you even start which variable you want to get rid of first, x, y, or z. Get rid of x. Okay, here's what I would say. If you're getting rid of x, you're going to have to tangle with an 8 and a 3, which is not bad because you have the x up above that has a coefficient of 1. If you tangle with the y, you're going to have to tangle with the 9 and the 4. But if you look at the z, I've got a 2 and a 2 and a negative 1. That might be a little bit easier. It keeps the number smaller. In the end, it doesn't really matter what you choose. So I'm going to go ahead and eliminate z. So here's what I'll do. I'll just take the top two this time. I'll take these two, and then I'll take these two. How does that sound? Or you know what? I could take any two together. Would it be helpful to take the first one and the last one? Yes, because those are already opposites, right? Uh-huh. And then I could take the bottom one, which is negative, or the middle one, also with the bottom one. So if you are being kind of smart, those would be the two best to pair up. So let's go ahead and do that. I'll take equation 1, 2, 3. Let me number them. So I'm going to take equation 1 and equation 3. So x plus y minus 2z equals 10. And then 3 is 3x plus 4y plus 2z equals negative 10. And now, because they are already opposites, I can add. So I get 4x when I add vertically here, and I get plus 5y there. The z's are gone, and here, oh, wow. What's 10 minus 10? 0. That is 0. Huh, that's interesting. That's equation 4. All right, then we do it again over here. We're going to have equation 2 and 3 now. So 2 is 8x minus 9y minus z. And 3 is, it's a little bit of rewriting, a little bit of writing all over the place, but writing is the easy part. Now I have to do something in order to eliminate the z here. What is that? I can't solve the system just yet because I have to get the coefficients the same, don't I? So I need to multiply the top one by 2 in order to make the z's opposites. So that's going to be 16x minus 18y minus 2z equals 5. And then we get 3x plus 4y plus 2z equals negative 10. And now we can add that system vertically. 19x, negative 14y, 0z, that's good, and that equals negative 5. That's equation 5. And now quick glance at the other one. We have x and y over there. We have x and y over here. It's good. That's good. Now we compose those together. So now we get 4x. And you can do this somewhere down below. You're just writing these now. Okay, and then now we're back in familiar territory. It's just two equations and two unknowns. Whoa, yeah, look at this. Which variable would be easier to get rid of? The y, yeah, maybe the y because they're opposite signs, right? But there's not going to be any like convenient number. So here's what we're going to do. When in doubt, you can always multiply by the other number. That's a 14, so I'll multiply the top by 14. That's a 5, so I'll multiply that by 5. And because they're already opposite signs, I don't need to multiply one of them by a negative. Now, I might have to do some stacked multiplication here. 14 times 4. What do you mean regularly? Like, how would you do it? You'd have to do it by substitution. But then you'd have to solve one of these for x and y, and then you're going to end up with fractions. I wouldn't mess with fractions at all. Yeah, I mean, you certainly can. You could solve them by substitution. You could solve them both for y and set them equal to each other. This might end up being easier because although the numbers are going to be a little bit bigger, you're not going to have fractions here. So you get 56x plus 5 times 14, 70y. 14 times 0 is 0. And then in the bottom, we get 5 times 19, which is 95, I believe. Minus 5 times 14, 70, right? And then we get 5 times negative 5, which is negative 25.
In the last one, we didn't multiply 2 times 5.
Did we forget something?
Yeah, right there.
Oh, that's why then. Oh, crap. You're right. Okay. Yeah. No. I made a careless mistake.
It doesn't really affect the equation we just did,
though. How did I miss that? Yeah, 16x minus 18y minus 2z, and then times 10. Yeah, let's fix that. Thank you for catching that. That just goes to show that doing these types of problems, careless mistakes are easy to make. So I'm going to change that to a 10, and look what happens now when I add those vertically. That becomes a 0. Now they both equal 0. Yeah. Good catch, Cannon. And then that equals 0. So that actually makes it a little bit easier. Because now when we add, now we'll add vertically, and we're going to get 151 x plus 0y equals 0. And what the heck? If I divide through by 151, what's 0 divided by 151? Yeah, 0 divided by any non-zero number. I'll write this right here. 0 divided by non-zero is 0. Okay. 0 divided by 0 is undefined. So now I got x equals 0. You get to the end here, you can kind of feel the funnel getting narrower and narrower as you go down. Now we get to bunny hop back up. So plugging that into either one of these, I'll probably plug it into the top one. So I get 4 times 0 is 0. I get 5y equals 0, which means y equals 0. What the heck? Yeah. But there's another letter to find. Now I got to find z. So I think I'm going to plug back into this one up here, the original. So I get y, which is 0, equals 10 plus 2z minus 0. So I get 2z equals negative 10. And that means z equals negative 5. Yeah. So it wasn't at 0, 0, 0. It's at 0, 0, negative 5. 0. Oh, up here? Oh, yeah. I didn't have to plug it in, but I wanted to show what I was doing. So here's kind of like what we usually draw if we're drawing like 3 dimensions. This is, it could be anything. This could be X, this could be Y, and this could be Z. Okay, it's kind of like having the corner of the room. You got moving along one wall, moving along the other wall, and then moving along the floor. So what would 0, 0, -5 look like? It would be 0 for X, so I don't move out this branch at all. I stay here. It would be 0 for Y, so I don't move up there. And then it would just be down 5, so I'd come down here, and it would be right here. So if you want to imagine where this would be, like if you try to imagine this room, 3 dimensions, just using this back corner, I could, if I were able to stand back, I think I can make it. Yeah. So this wall would be like your X axis right here, your X plane. And then this wall could be your Y plane, and the floor is your Z plane. So I don't go down this wall at all. I don't go down that wall at all. Assume that I'm at the bottom of the corner there. And then what does -5 mean? I have to go below. I go downstairs into whoever's room is there. Yeah.
Or you
But
could say if you're looking at like in the door.
oh, it could be. Yeah, maybe. I don't know what that meant. You mean looking in a door?
No, I mean like say so if you're like looking at a piece of paper with the axis, x-axis.
Yeah, yeah.
Instead of thinking like downstairs, because like when you said that, I thought like down instead of down.
Oh, I mean like going under the floor. Down.
Yeah.
Yeah.
See it
Yeah.
now.
Yeah. Anyway, that's what 3 dimensions is, X, Y, Z, X, Y, Z. But yeah, that's it. It's there's only 2 examples. The here's the skinny on, yes. Yes, but listen to this quickly before you leave. I was told that on the test, you are not going to have to algebraically solve a 3 by 3 like this. You're not going to have to. But this will be the bonus question. You know how there's extra credit on every test? Some of y'all try it, some of y'all succeed, some of y'all leave it alone. This will be the bonus on the test. So in addition to the extra credit that is separate, if you could do one of these, you got more money in the bank on the test. So yeah, I just wanted you to hear that. You can go. Yeah. The test is next Thursday. Yeah. For this, I'm going to make this homework due like Tuesday. Yeah. All right. So homework is due Tuesday, and this is the bonus on the test.
Are we gonna have time to work on it on Monday too, or no?
No, we're doing the next section on Monday. But you might. You have time right now. I'm going to turn the rest of the class time over for you to do this. The last section in this chapter is solving these systems of equations, but doing it entirely on the calculator using what's called matrices. Did y'all study matrices in Algebra 1? No. Okay, so I have to introduce to you what a matrix is, a matrice is, and we're going to be solving these by matrix multiplication. It's basically how the big time computers solve things like this. All right, but we'll save that for next time. So the rest of the time is yours. You can work on the homework. You can work on whatever else you think you need to. And yeah, have a good weekend.